Hello everyone, welcome back to another lesson of number sequences. Today we are going to be investigating arithmetic sequences. Before we look at our concept map today, I'm going to ask you a question. Have you ever thought about patterns that occur in real life? Maybe there's something that happens at regular intervals, or maybe you see that certain prices of things increase at a certain rate. Patterns are everywhere, and today we are going to be focusing on arithmetic sequences. Let's have a look at our concept map. So, I have discussed this in previous lessons, but in case this is your first time with us today, we have discussed that arithmetic sequences have a common difference. So this is the property of an arithmetic sequence. Firstly, I'm going to be talking to you about the general form of an arithmetic sequence, which is Tn is equal to A plus n minus 1 d. Just a note to remember that A is representative of the first term of a particular pattern, and D is the common difference. Before we look at an example, I'm just going to go over some important definitions that are important for you to have at the back of your minds as we go through this section. Please remember that a term number refers to the position of the term in a sequence. Tn is the nth term of the pattern, where n is the term number. So for instance, if I say T1 is the first term of the pattern, T1 is the first term because n is equal to 1. T3, where we can see that n is 3 because of that subscript, T3 is the third term of the pattern. As I've already mentioned to you guys, n is 3. So just a reminder, the n refers to the term number. Then we move on to the definition of term value. Term value refers to the actual value of the terms. This is not the term number. This is the actual value of this term. So if I say T7 is equal to 334, I hope that everyone's with me, that means that the seventh term has an actual value of 334. The term number is 7 because it's in the seventh position of the sequence, but the value of the seventh term is 334. Please make sure you're comfortable with the differences between term value and term number. Let's look at the next slide. So we've already mentioned common difference, but please just remember that the common or constant difference is the difference between any two consecutive terms in a linear sequence. So if I give you the pattern 2, 4, 6, 8, 10, we can see that we have a constant difference of positive 2 between the consecutive terms, and because I have that constant difference, it is a linear pattern or a linear sequence, but we can also call this an arithmetic sequence. Okay, the next definition, everyone, is the general term. The general term is a mathematical expression that describes the sequence and that generates any term in the pattern by substituting different values for n. So, this means that the general term is a mathematical rule where I can substitute in n values or term values. So if I'm substituting in term numbers, I will be able to determine the actual value of that term. Or alternatively, you could be substituting in a term value to determine which term actually has a value that is given to you. So let's have a look at the next slide. So we've discussed that a common difference is present in arithmetic and linear sequences. Now I'm going to write down how we can actually determine the common difference. The main way that we do this is we often say that the difference is equal to term 2 minus term 1. And we normally check to see whether this common difference is correct by then doing term 3 minus term 2. But in general, we can define the common difference to be that the common difference, d, is equal to t n minus t n minus 1. What this means, everyone, is the common difference can be calculated for a linear sequence by taking the value of a term and subtracting the value of the term that comes before it. So I'm going to say that again for everyone. The common difference can be found by taking the value of a term and subtracting the value of the term that comes before it. Let's have a look at the next slide. So we are now going to generate an arithmetic sequence. We've already discussed that T1 is equal to A. If I'm looking at term 2, I'm sure everyone will agree with me that's going to be A plus D, because it's A plus 1 difference. So I actually don't need that other equal sign over there. If I'm looking at term 3, it's going to be A plus 2 differences, because I have now said it's A plus a difference plus another difference. Term 4 will be A plus 3 differences. Term 5 will be A plus 4 differences. So we can see that if we link it back to term 1, there were no differences added for term 1. Then moving down, I added 1 difference, then 2 differences, then 3 differences, then 4 differences, and this pattern will continue going on. So that's why I can say that the general term is equal to A plus n minus 1 D. So for term 4, we added 3 differences. For term 5, we added 4 differences. For term 3, we added 2 differences. So because of this pattern, we can then say that as we know that the general form of an arithmetic sequence is equal to A plus n minus 1 D, I can actually write down the formula for any term with any term number. So term 32 would be equal to A plus n minus 1, and in this case, n is 32. So it's going to be 32 minus 1d. So term 32 will be equal to A plus 31d. And this is going to help me because I can actually skip this step moving forward. Because I could say that term 15 is equal to A plus 14d. I'm hoping that everyone can see that the coefficient of the d is always 1 less than the term value. So term 16 will be A plus 15d. Term 20 will be A plus 19d. After the break, we're going to look at some more examples of arithmetic sequences and how the formula behind me can help me.